Hello and welcome to lesson 4.3a, Slope-Intercept Form. Our objective today is that I can rewrite equations in slope-intercept form. Now, what is slope-intercept form? It is an equation in the form y equals mx plus b, where m is the slope and b is the y-intercept. So we are going to go through example 1 here where we are writing things that are in slope-intercept form. So letter A, I'm given that we are going to write an equation for a line with a slope of -5 and a y-intercept of 3. So our generic form is y equals mx plus b. And we are going to find two of our values. So our slope is -5, and that's our m. And our y-intercept is 12, and that's our b. And so we are just going to substitute those values in. Y equals m, -5, times x, plus our b value, which is 12. Letter B, we're doing the same thing. We're finding those pieces of information. My slope is 4/7, and my y-intercept is 5. So if I write that in my generic form again, y is equal to my slope, 4/7 times x, plus my y-intercept of 5. All right, so you get y equals 4/7 x plus 5. I would prefer that you leave these as your fractions when it comes to your slope, because that is an advantage of slope-intercept form. It helps us graph, and the fractions make things easier to graph with. All right, let's look at letter C. We want to know what are the slope and y-intercept of the equation y equals -1/2 x plus 3. Well, the slope is what's attached to x, and remember the sign in front of a number is connected to it, and the plus 3 is going to be my y-intercept. So slope is -1/2 -1/2, and my y-intercept, b, is going to be equal to a +3. Letter D, what are the slope and y-intercept of this given equation? My slope is what's attached to the x. My y-intercept is the constant that's being added or subtracted at the end. And so my slope, m, is equal to 3, and my b value is equal to -6. All right, now there are 4 you try it problems that I would like you to do on your own, and then we'll go over them as a group. Letter E, we are looking for an equation with a slope of 2 and a y-intercept of 7. So we're going to go ahead and write that equation. Y equals 2 times x plus 7. Letter F, what is the equation of the line with a slope of 4/3 and a y-intercept of 9? So again, we have our y equals, what is my slope? Slope is 4/3. My y-intercept is 9. So if we go back and substitute that in, 4/3 goes in for m times x, and we are adding 9 to it. Now let's take a look at letter G. What are the slope and y-intercept of the equation y equals 3/2 x plus 6? So again, we're going to look at our equation. My slope is what's attached to x, and my y-intercept is the constant that's being added or subtracted. So if I find those values, my slope is equal to 3/2, and my y-intercept is equal to 6. So now we're going to do example 2, which is rewriting linear equations in slope-intercept form. And I want to convert what they're in to slope-intercept, which means that my goal is going to be, I want to isolate my y variable. So in order to isolate the y, my first step is going to be to add 6 to both sides. And we're going to get 2y is equal to 3x plus 6. My next step is going to be to divide all of my terms by 2. And when I simplify my fractions, we're going to be left with 3/2 x plus 3. We're going to leave that as a fraction. I'd rather you not write 1.5 or 1 1/2. Those would be technically correct, and I would not mark you off for them. I would just prefer that you leave it as a fraction because fractions will make it easier for us to graph our equations. All right, letter B. We need to start by doing the distributive property on the right side. So I'm going to get negative 2y because nothing happens over there. We have 6 times 5 is 30 minus 6 times 3x is 18x. Now I'm trying to get y by itself, so I'm going to divide by negative 2 all 3 terms, and I get y is equal to negative 15 plus 9x. Now you might be sitting to yourself and looking at that and saying, well, that's not in slope-intercept form. The constant is first, the rest of it is after. This doesn't make sense. Well, if you remember, the commutative property of addition says that we can switch these around, so we can do negative or 9x minus 15 as our equation, because we can swap things around if they're being added in the same order or in a different order. All right. Letter C. Actually, going back to letter B for a moment. The technical correct way to write this is this right here. We haven't taught you all of the rules of exponents where you are writing them in decreasing degree order. What you should just know is that your variable term is going to come before your constant. So 9x will come before negative 15 in the standard format. All right, letter C. Our first step is we want to get y by itself. We're still trying to isolate that right there. So my first step, I'm going to add 22x to both sides. And I'm going to get that 8y is equal to 22x plus 4. My next step is divide everything on both sides by 8. I get y is equal to 22 over 8. Well, they're both even numbers, so I can divide both of them by 2, and I'm going to get 11 over 4 times x. And then 4 over 8 is going to simplify to 1/2. And that's my final equation. At the top of the next page, there are 3 U-try problems that I would like you to do on your own, and then check your work against mine. So letter F, we're trying to isolate y. So I'm going to add 2 to both sides of my equation, and I'm going to get that y is equal to negative 3x plus 2. It's just that simple. Letter E, we are going to start by adding 16x to both sides. And I'm left with negative 4y is equal to 16x minus 56. And make sure you keep this negative sign. It needs to come down with it because it's attached to the 4. So I'm going to divide by negative 4, and I need to do that to each of my 3 terms. And we get that y is equal to 16 divided by negative 4 is negative 4x, and negative 56 divided by negative 4 is plus 14. Letter F, we're going to have to do distributive property. And so we do that. We get negative 6x minus 8 plus y equals 0. My first step is going to be to add 6x to both sides. And I'm left with negative 8 plus y equals 6x. Then my next step will be to add 8 to both sides. And I get that y is going to be equal to 6x plus 8. Now, example 3 is all about writing linear equations, and you'll notice I'm not giving you very much room. That's because all we're doing is we're writing an equation based on the story that we're given. So in letter A, the number of job openings in the United States during a recent year increased by an average of 0.06 million per month since May. In May, there were about 4.61 million job openings in the United States. Write an equation in slope-intercept form to represent the number of job openings in the US in the months since May. So we need to find out what are my pieces of information that are important. And when it comes to slope, when it comes to word problems, you're going to look for things like per. The word per is going to be a trigger that you're looking at a rate for the most time. That's your rate of change. Or if you're going to see rate, right? It's a rate. That is what we're going for here. The slope is the rate, and your y-intercept, your b value, I'll just do this, your y-intercept is going to be your starting amount. And my iPad's being stubborn. So that's our starting value, our y-intercept. So when I read this again, with that in mind, I'm looking for a starting value and I'm looking for a rate. My starting value, I'm told, is going to be 4.61 million job openings. And my rate is increasing by an average of 0.06 million per month. So now when I go to write my equation, y is going to be equal to my rate, 0.06 times x, and we're adding to that the 4.61 million job openings there are. Now, why am I not writing million job openings, or why am I not writing the 4.61 million and just put a bunch of zeros there? Well, we can treat this and this as both part of the units. So when it comes to when we're saying, something million, you can treat that as part of the units as long as you're aware that we're talking about 0.06 million and 4.61 million. And did you see the fancy highlighting where you overlap different highlighter colors and they change colors? Yeah, we're going to learn about that in optics during our science lessons later on this year. All right, letter B. In the first quarter of 2012, there were 183 million users of a popular social media site in North America. The number of users increased by an average of 9 million per year since 2012. Write an equation that represents the number of users in millions of the social media site in North America after 2012. Well, first thing I want to find is how much are we starting with? And my starting value is there were 183 million users. And then what am I changing? What is my rate of change? Well, I'm looking for keywords, and increased is going to be a keyword. And we're going to just go ahead and underline that. Increased is a keyword. Increased or decreased, they're telling us we have a change. And then there's that word per again that's telling us we have a rate. So now we have our rate, we have our starting value. So y is equal to our rate, 9 million per year, times number of years, plus our starting value of 183 million. And again, the million is included in the units, so we don't need to include that in our equation. All right, so now we're going to look at letter C. A computer repair company service charges $50 for diagnostics and $35 per hour for repairs. If X is the number of hours it takes to repair a computer and Y is the total cost of the repair, we want to figure out what is our equation. So my rate, I have a $35 per hour for repairs, and we're starting with $50 for diagnosis or diagnostics. So I write my equation, y is equal to my slope, 35, dollars per hour times the number of hours. So if we know that's dollars per hour times hours, what cancels out? The hours cancel out and we're left with dollars. All right, and now we're going to add in our starting value, which is $50. So no matter what, you're paying that $50. Letter D. Suppose you have a $5 off coupon at a fabric store. You buy fabric that costs $7.50 per yard. Write an equation that models the total amount of money you pay if you buy X yards of fabric. Now, if you don't know this, fabric is going to cost you it's going to be sold by the yard, so 1 yard long, and you can buy fractions thereof. So we have our rate and we have our starting amount. Our starting amount is $5 off, and our rate is $7.50 per yard. So my equation, y is equal to 7.5 times x, and this is going to be plus -5 because it's $5 off, so that's negative. All right, there are 4 you-try problems to finish off the lesson that I would like you to do on your own. And go ahead and get started. Letter E, the temperature at sunrise is 65 degrees Fahrenheit. Each hour during the day, the temperature rises 5 degrees Fahrenheit. Write an equation that models this scenario. So my starting value is temperature at sunrise is 65 degrees. Each hour during the day, the temperature rises 5 degrees. And now I need to write my equation. Y is going to be equal to my rate, my 5 degrees per hour, times the number of hours, plus my starting temperature of 65. So it's y equals 5x plus 65. Letter F. A plumber is charging a fee of $65 for repairs plus $35 per hour for the work that he's doing. Write an equation to model the total cost y of a repair that takes x hours. All right, so we need to put in our rate, which is $35 times dollars per hour times the number of hours, plus the flat fee of 65. Y equals 35x plus 65. Letter G. Polar bears are listed as a threatened species. In 2005, there were about 25,000 polar bears in the world. If the number of polar bears declines by 1,000 each year, write an equation in slope-intercept form. All right, so our starting amount. We're starting with 25,000 polar bears in the world. What is our rate? It is declining by 1,000 each year. So we're going to go ahead and write our equation. Y is equal to our slope, -1,000 times x, plus our starting amount, 25,000. Okay. And letter H. Suppose you are doing a 5,000 piece puzzle. You have already placed 175 pieces. Every minute you place 10 more pieces, write an equation to model the number of pieces that are placed. So every minute you place 10 more pieces. That sounds like my rate. You have already placed 175 pieces. That sounds like my starting amount. So we're going to write our equation. Y is equal to my slope, 10, times the number of pieces, or number of minutes, x, and we're adding what we already have done, which is 175. Now, you might be asking yourself, well, what about the 5,000 piece puzzle? Is that information useful? It's actually not. That's a distractor. So what you might see is a problem on IAR, or a problem on MAP, or a problem on the Illinois Science Assessment, or eventually the ACT, SAT, whatever you may take, they're going to sometimes include extra information in a problem that you need to be able to identify what is the important information or not. In this case, if we're talking about writing an equation to model the number of pieces placed, do I care about what the total number is right now? No, I care about how many I have on the table already. So the 5,000 is unnecessary. Now, if there were to be a subset of this question, if there was a part B of the question that asked, how long would it take to place all the pieces? Well, now you would be able to use that 5,000 and substitute it in for y and solve for x to give you the time of how long it would take to place all of the rest of the pieces. But that's not what we're asking for here. We're just asking for an equation that's going to model how many pieces have been placed down. So that's why the distractor is unnecessary information that we can just cross out and skip over. All right, that is the end of our notes for today. If you have any questions, please feel free to reach out or bring them to class tomorrow. Otherwise, have a great day.